In this video, we're going to cover a little bit more information about the MR-1 spindle, how to load tools into it, what type of collets it uses. And then we're also going to cover, starting it, running it up through its speed range. Now it's important to note that, you should have already run the spindle on your machine through the MR-1 break-in program, that is downloadable on our website. If you haven't done that, you need to pause this video, go back, run through the spindle break-in program. We want to break in those bearings before we do any cutting on the machine. With that being said, a little bit about the MR-1 spindle. It is an ER20 collet spindle, so it uses collets such as these. You can clamp on anything from about 1/16 of an inch all the way up to 1/2 of an inch. You'll receive in your kit 2 collets. They're included. One of them is a 1/4 inch collet. The other is 3/8. These are collets that we've had manufactured. We control the run out and the accuracy to an extremely tight tolerance because there's lots of different collet manufacturers out there, but not all of them are going to have as good a run out as the some really high quality collets, including the kits that we sell on our website. So we sell a kit of 14 different collets. If you haven't picked up a collet set, strongly recommend you consider purchasing that one from us. With that being said, we're going to show how to load this 1/2 inch collet with a 1/2 inch end mill because subsequent to this video, we're going to actually be surfacing our base plate, and we're going to be using a 1/2 inch end mill to do that. Speaking of end mills, for that task, we're going to be using one of our end mills. This is the Linear Systems end mill. This is purposefully designed for our machine. It's a 2-flute end mill. It's got high helix angle. It's got variable pitch and also variable flute. So really good high performance end mill. We spent a lot of time developing these end mills for aluminum cutting and also for steel cutting. We have a steel cutting variety, but if you're not going to use our end mills, strongly encourage you to use for aluminum, use end mills that are have the specific geometries needed to cut aluminum. That's, high helix angle, variable pitch, variable flute. For steel, you're also going to want to have variable pitch, variable flute. 4 cutting teeth is typical for cutting steel. And then you're going to want to have the right type of coating, for steel cutting. For this video, we're going to show you how to load this up. So like I said, we use collets, to hold on to our tools and our spindle. Here's our 1/2 inch collet. What's most important about collets is cleanliness. Cleanliness is extremely important, both in terms of the cleanliness of the collet itself, the cleanliness of the collet nut, and then also cleanliness of inside the spindle paper. If there's any dust, debris, chips, anything like that are on any of these critical surfaces, it's going to prevent intimate contact from occurring in that taper. You're going to get run out. You could potentially have tool pull out issues. It's going to affect the accuracy and the surface finish. So number one most important thing is check all of these. Use compressed air, blow out any chips or debris. Feel with your fingers in the taper of both the collet nut and the taper of the spindle. Make sure it's totally clean. That's the step one. So step 2 is you take your collet and you just snap it into the collet nut. You're going to feel it snap. And if I flip it over, you can see that the front edge of the collet is flush with the surface of the collet nut. That's proper assembly. If you have it where it's kind of in there like this, not all the way in, and you go and try to install that, it's not going to be an appropriate assembly. You're going to have issues. So make sure you listen for the snap, get it snapped in. That's step 1. So step 2 is then to screw it onto the nose of the spindle until you feel a little bit of resistance, and then just back it off a few turns. We don't want to be clamping on that collet yet. Then I'm going to take my end mill. I'm going to make sure that my shank is clean. There's no debris or dirt or anything on there. And I'm going to go and put it up into the collet. Now, I'm not going to shove this all the way in there. The key with collets is you never clamp onto the flutes. You always want to be clamping on a solid diameter. And so my flute is ending right around right there. So I'm going to go ahead and just clamp. I'm going to push the tool all the way up until that flute is just slightly exposed out of the collet. Next, I'm going to take my spindle wrenches. These come with your kit. One end holds onto the spindle, the other end holds onto the collet nut. So I'm going to go ahead and tighten this up.
And you just want to get a good, nice, snug fit.
If you have issues with tool pullout, it's likely because you're not tightening your collet enough. So be mindful of that. So now I've got it. Now I've got my tool in there. It's ready to run. I'm going to jump over to the controller, and we're going to go over how you manually control the spindle, such as if you wanted to just do some manual work, like if you wanted to face something off or go and run a profile around something and you didn't want to generate a program, you'll need to know how to turn the spindle on. So I'm going to jump over here. So here I've got this button that says manual spindle control. I'm going to go ahead and click that button. And I've got a couple of different options that I can select. These are preset spindle speeds. I can select 1000, 6500, 2500, etc. Or I can come into this box and I can enter any spindle RPM that I want. Once I've selected the speed that I want to operate at, I can go ahead and just hit the spindle on button. And as you can see, the spindle is now spinning at 1000 RPM. So jumping back over to the control, I've got this live values box, and you can see here that spindle is running at 1000 RPM. Now, if I come over to my spindle overrides, you can see spindle overrides. I have two options. One is I can increment and plus 10%, or I can increment and plus 1%, or down 10% or down 1%. So if I just click up on this plus 10, you can see on the DRO that I'm now spinning at 1100 RPM. If I just go and click that a handful of times, you can see that the spindle is progressively getting to a faster speed. If I want to go ahead and refresh it back to the default setting, which was 1000 RPM, I would just hit the refresh button next to the percentage. Now I'm spinning at 1000 RPM. If I want to come through here while it's running, I can come and click higher speeds. Now I'm running at 2500, 5000, 6500. Now that's spinning at 8000 RPM. Then to turn off the spindle, it's a simple matter of just hitting the spindle button. Now the spindle's off. And with that, I can now move on to doing some cutting. In the next video, we're going to be surfacing the base plate with a 1/2 inch end mill. So stay tuned for that.